Hey guys, Alex here. I have a new update for the ICU ventilator that we've been working on. So this is how it looks. I'll show you the circuit and I'll show you the control that we've got. We used an ambu bag and we added this strap here to press it down. Sometimes the balloon won't go back to its position. Most of the time will, but sometimes it gets locked. Okay, so from the ambu bag we go through a flow meter made of a Venturi tube. These two ports are used for the flow meter and this one is for the pressure. We have three sensors, three pressure sensors, two for the inhale and one for flow meter on the exhale. Right here. After that we go through a filter, then it will go to the patient valve. This one is the inhale and exhale valve. It's the same valve from the ambu bag and with the PIP connector. Then we go to another filter, to the flow meter and to this PIP valve right here that we set the PIP. So right here we have another pressure piece that shows us that the pressure we measure with the sensors is alright. So I will show you the controls now. Tilt this a bit. It's hard to see. Alright, so we have the mode and we have two modes implemented right now. We have the pressure control where you can set the pressure. Usually it's around 20. You have the breaths per minute, set it to 50, and then you have the inhale and exhale ratio. Let's go to 1, 2. Once you set it, you'll see that it goes to 20 and keeps it there for the inhale time. So at the top we have the pressure in millimeter H2O. Then we have the flow in liters per minute, and then you have the volume, the tidal volume. Alright, let's try a different ratio, for example. Here we have the peaks. We'll be adding more information down here in the future, but we focused on getting the system running properly and getting the sensors calibrated and control the motors. Control the motor to keep it at the set pressure. Alright, so that's pressure support, pressure control, and then we have the flow control. Let's go here, set it to around 500 breaths per minute. And then you see that the pit is done on the flow right now, so I will try to keep it at the set flow. We still have to get rid of this peak right here. But that's not a big problem because it's for a fraction of a second. And here you have the volume that we set. Go for 600. Yeah, so we also have some things that we've done on the back to allow the oxygen mixture, and this is how it looks. So we have this connected to the oxygen supply, which in my case is this cylinder right here. We set it to 9 liters per minute, and then we have this venturi tube that's used to mix the oxygen with air. So we have multiple venturi tubes from 30 to 60% oxygen. The bag fills with mixed oxygen, and the ambu bag will draw oxygen directly from here. So this way you're sure that your mix is properly done. These venturi tubes are calibrated and tested that they provide a proper mix of oxygen. This project is open source, and we're going to update the plans within 1 or 2 days. We're trying to get everything straightforward so people can install it on their machines or on their prototypes, because once you have the mechanics going, then it's going to be easy to modify the code to make it work with your mechanics. We're also working on a version based on the Medtronic, and this is how it looks so far. I'm not going to go into too much detail about this because it's still work in progress, but we're going to get the software from this version onto that, and instead of controlling the stepper motor, we're going to control the turbine. So this is it for now, guys. If you have any questions, don't hesitate to write it in the comments or contact me, and we'll help you make this project work for you as well. Have a great day.